So we have the function log of secant x plus tangent of x. So we need to find its derivative with respect to x by using the chain rule. So let us begin by assuming that secant of x plus tangent of x is equivalent to x. If that were the case, then what we have to do is only find the derivative of the logarithmic function, which is 1 over x. So that means we should get 1 over x. So x here is secant of x plus tangent of x. But since it is not x, so what we have to do, we have to multiply it to the derivative of our assumption, which is secant of x plus tangent of x. Now we find the derivative. So derivative of the secant function is secant of x times tangent of x plus derivative of the tangent function is secant squared x whole divided by secant of x plus tangent of x. Now we are going to take secant of x common from the first two terms in the numerator. So we will have tangent of x plus secant of x divided by secant of x plus tangent of x. Now we can cancel out tangent x plus secant x from both the numerator and the denominator, and the final answer is secant of x. So this is the derivative of our given function which has been found by using the chain rule. Let's move on to the next question. So here we have the exponential function given by e raised to the power of x sine x. So let us find out its derivative with respect to x by using the chain rule. Now we have x sine of x in the exponent. So if we assume that x sine of x is equivalent to x, then we have the derivative of the exponential function, which should give us the function itself. So that means we would get e raised to the power of x sine x. But what we have to do, we have to multiply it to the derivative of our assumption, which is x sine x. Now x sine x being the product of two functions, so we're going to use the product rule. So we have e raised to the power of x sine x multiplied to, so we're going to consider x as the first function, so we multiply it to the derivative of the second function, which is sine of x, plus the second function sine of x multiplied to the derivative of the first function, which is x. So we get e raised to the power of x sine x multiplied to x times derivative of the sine function is cosine of x plus sine of x times derivative of x with respect to x is 1. So this is the derivative of the given function e raised to the power of x sine x obtained by using the chain rule. Let's move on to the next question. So here we have logarithm of 2 to the base of x. So let's try to find out its derivative with respect to x. But before that, we have to change the base of the given function, of the given logarithmic function, to e from x. So we're going to use the definition here that log of a to the base of b is equals to natural log of a divided by natural log of b. So we'll have natural log of 2 divided by natural log of x, which can be rewritten as natural log of 2 times natural log of x raised to the power of negative 1. So now let's find out the derivative of log of 2 to the base of x with respect to x, which is the same as finding the derivative of log of 2 times log of x raised to the power of negative 1. The log of 2 being a constant, it can be pulled out of the derivative. So we have natural log of 2 multiplied to the derivative of log of x raised to the power of negative 1. Now here we are going to make an assumption that if log of x were equivalent to x, then we have the derivative of x raised to the power of negative 1. Now if we apply the power rule, then we should get negative 1 over x squared. So that means we have log of 2 multiplied to -1 divided by log of x whole square. Then we need to multiply it to the derivative of our assumption, which is log of x. So we finally get log of 2, negative log of 2 divided by log of x whole squared, and derivative of the natural log is going to be 1 over x. So this is the derivative of our function, which is log of 2 to the base of x. Let's move on to the next question. So here we have the function e raised to the power of the exponential function. So we need to find the derivative with respect to x. Now what we're going to do, we are going to assume, or we're going to imagine that e raised to the power of x is equivalent to x. So that means we have the derivative of the exponential function, which gives us the function itself. So that means we will get e raised to the power of x. So x here is our assumption, which is e raised to the power of x times derivative of our assumption, which is e raised to the power of x. So that gives us e raised to the power, the exponential function, multiplied to the derivative of the exponential function, which is the function itself. So this is the derivative of the given function with respect to x. Let's move on to the next question. So here we have the function log of x, the base of 7. So we need to find its derivative with respect to x. But before that, what we will do is we're going to change the base of 7 to the exponent e. So we're going to apply the definition here that this is equivalent to the natural log of log x to the base of 7 divided by natural log of 7. So that means we have now the base is e. Now we were going to apply the derivative to this particular function. So we have 1 over natural log of 7. So this has been pulled out of the derivative because it's a constant. Now we're going to find the derivative of the natural log of log x to the base 7. Now we're going to make an assumption here that log of x to the base 7, if it were equivalent to x, or if it were x, then we would only have to find the derivative of log of x, which is simply 1 over x. So that means we'll have 1 over log 7 times 1 over log of x. But since it is not x, so we need to multiply it to the derivative of log of x to the base 7. Then again, we are going to change log of x with base 7 to natural log of x divided by natural log of 7. So that should give us 1 over log of x to the base 7 multiplied to natural log of 7 times the derivative of natural log of x divided by natural log of 7. So 1 over natural log of 7 being a constant, we can pull it out of the derivative. So we will get natural log of 7 whole squared. So let's get rid of this natural log from here. So we have to finally find the derivative of natural log of x, which is simply 1 over x. And our final answer is going to be 1 over x multiplied to log of x to the base of 7 times natural log of 7 whole squared. So this is the derivative of the given function with respect to x. Let's move on to the next question. So here we have the function square root of 1 plus x over 1 minus x. So we need to find its derivative with respect to x. So what we're going to do here, we're going to make an assumption here that let this function be actually equivalent to y. Now, in doing so, what we're going to do here, we are going to square both sides of the given equation. So that gives us y squared is equals to 1 plus x over 1 minus x. Now we are going to differentiate both sides with respect to x. So we have derivative of y squared on the left hand side equals to the derivative of 1 plus x over 1 minus x on the right hand side. Now the derivative of y squared is going to be equals to, now here if we make an assumption that our y is equivalent to x, then what we have here is actually derivative of x squared, which we can find out its value to be equals to 2x times raised to the power of 2 minus 1, which gives us twice of x. So that means we will have 2 times y raised to the power of 2 minus 1 multiplied 2. Now since y is not actually x, that's only an assumption that is equal to x, so we have to multiply it to the derivative of y with respect to x. Now for the right hand side, what we can do here is we can apply the quotient rule to find the derivative. So we have 1 minus x in the denominator, so we take it and square it and write it in the denominator. Then we begin with the same denominator 1 minus x and multiply it to the derivative of the numerator, which is 1 plus x minus 1 plus x multiplied to the derivative of 1 minus x, so which gives us 2 times y multiplied to dy over dx equals to 1 minus x times, so derivative of 1 is 0 and derivative of x is 1, so we get 1 here minus 1 plus x multiplied to derivative of 1 is 0, so minus derivative of x is negative 1 divided by 1 minus x whole square. So the negative and the negative will get multiplied to become 1 minus x plus 1 plus x divided by 1 minus x whole square, and we have 2y times dy over dx in the left hand side. So negative x and positive x gets cancelled, which leaves us with 2 over 1 minus x whole square. So we divide now both sides by twice of y, so that gives us dy over dx equals to, so 2 divided by twice y multiplied to 1 minus x whole square. So 2 and 2 gets cancelled, which leaves us with 1 over y times 1 minus x whole square. Now we go back to our assumption. So we have assumed that y is equals to square root of 1 plus x divided by 1 minus x. So d over dx times square root of 1 plus x over 1 minus x. So what we have done, we have substituted for the value of y is equals to 1 over square root of 1 plus x over 1 minus x multiplied to 1 minus x whole squared. So that will be equals to the square root of 1 minus x divided by square root of 1 plus x multiplied to 1 minus x whole squared.